Hello. Hello, I am Richie. I'm a rising sophomore at Lynbrook High School, and this is the phone-controlled robotic arm project. Me and a few others will be explaining different parts of the project. So the arm is quite simple. It's controlled by 4 servos powered by the ESP32 chip and a battery pack. The ESP32 is a microcontroller that can connect to your phone with Bluetooth. And then the app, it has sliders to control the servos. I used the modification I added. It's an ultrasonic sensor. It will make the claw close automatically when something is in range. I'll do a short demonstration. So this is the app, and I can tap around on the sliders to make the arm move around in different directions. And I can also use the automatic claw feature. Basically, what it will do is when I bring something close to the sensor, the arm will automatically close around it. And then when I bring it away, it'll open. So that's the end of my demonstration. So the hardest part of this project for me was getting the sensor to work. It took many hours of coding and troubleshooting to get the code to work. And the coding was the most difficult it was a lot more difficult than the building. Like it was way harder. And then my favorite part of the project was also getting the sensor to work because of how difficult it was. It felt really good for me when I finally got it to work. And it also taught me a lot about coding with different microcontrollers like Arduino and this ESP32. And the coding part really stuck out to me more than the building because I feel like coding is a lot more fun. And if I were to continue working on this, I would probably focus a lot on coding new things into the app or new features. Thank you. Does anyone have any questions?
Awesome job, Richie. What would you say? I'm just gonna ask, like, you have a future modification. One thing you could add onto the project right now, it'll instantly appear on your project. What would you want to add?
I think I would want to add the ability for like the claw to be able to hold more things because right now it's kind of weak. But if I could get it to hold like something like a pencil or a pen, it would be really awesome because I could let it like draw with it. It'd be really cool.
Yeah, that would be super duper cool. Awesome job, Richie. Yeah, anyone else have any questions, or if not, we can move on. Awesome job, Richie. So next up is Abdurrahman. What I can really say about Abdurrahman is sometimes he would miss class, but he would 100% make it up in office hours. He'd come to office hours anytime after class if he thought he was lacking behind. So like it really shows like he really was going to persevere throughout the entire time. Yeah, so everyone give it up for Abdurrahman. Abdurrahman, you ready?
Yeah, I am.
All right.
Hi, everyone. Hello, everyone. I'm an incoming junior at Lynbrook High School in California, and my project is the phone-controlled robotic arm, which uses Bluetooth connection and an application made in Android through the MIT App Inventor to control the robotic arm. So first of all, I'm going to show you a short demonstration of my robotic arm working. So I think you guys can see it over here. And this is my application. So the first thing I'm going to do is connect it to Bluetooth. And it's connected and move the claw of the robot. And these sliders move the exact position that the robot is going to go in. Yeah, so that was the end of my demonstration. And so like the part I'm going to be focusing on in my presentation are the servo motors and PWM. So this right here is a servo motor, as you can see. So a servo motor is like a small device that has an output shaft. And the shaft can be positioned to a specific angular position by sending the servo a coded signal. And as long as the coded signal exists in the output line of the code, the servo will maintain the angular position of the shaft And if the coded signal changes, the angular position of the shaft also changes. And so the servo motor also has a digital control just like DC motors, but they can be converted to analog signals, which allows the servo to go to a specific angle, and it is able to do this through PWM. We are using the servo motors instead of DC motors because you can make sure that the servo motors can go to a specific angle as opposed to just running around as a motor like the DC motor, which will give us like a much more control on the robotic arm. So now I'm going to share my screen and show you a graph of how PWM exactly works. So over here, PWM basically means pulse width modulated control, which allows a digital signal to replace an analog voltage. It is a method of reducing the average power delivered by an electrical signal by effectively chopping it up into discrete parts. So this is the graph. And as you can see on the graph, there's this F, which stands for frequency. And so if I press play on the frequency, it's going to change the pulse at which the electric current is going through the motors. And then down here, when I press play on the A, it's the average voltage changes over here, as you can see. And in this graph, one refers to high voltage and 0 refers to low voltage. Through PWM, we are able to take in voltage that is in between 0 and 1, which basically creates an infinite number of possibilities through which we can take in the power and control the servo motors. And so that's a demonstration of PWM. And one modification that I did is that I added an ultrasonic sensor to my robot. Making this project was that my ultrasonic sensor was not working correctly when I connected it to the ESP32, but it was working when I connected to the Arduino Uno. So in order to fix this problem, I went back to the code and I changed some things to make sure that all the code fits in with the ESP32 libraries. And then I checked the pins, and after that, it started to work again. And some lessons I learned through making this project was that I was sort of skeptical on how I would be able to code the robotic arm to make it work. But with some practice and debugging, I was able to complete the project. And through all of the fun and challenging experiences in BlueStamps, I was able to learn a lot of new things, as well as enhance my computer science and engineering skills this summer. Thank you.
Awesome. Great job, Abdurrahman. Anyone have any questions for Abdurrahman? And let me just ask, what was your favorite part to work with? Did you like the ultrasonic sensor, using the app inventor, servos? What was your favorite part?
I think the main thing for me was making the application, because it actually helped me like to actually move the arms like automatically without having to code it myself. Yeah. So yeah.
That was awesome. Great job. Awesome. So I realized I forgot to mention this earlier. Since we have 5 robotic arms, each student's going to tackle a different component of the arm. So Richie gave the introduction. Abdurrahman just talked about the servo motors. And next up, we have David, who's going to talk about actually making the app. David, like whenever I would ask him, like, "Oh, what are you up to, David?" Like making sure he's up to code, he'd always be one step ahead of what I asked. So like, he was always one step ahead of the game. And with that note, David, are you ready? All right, let's go, David.
Hi, I'm David. I'm a rising junior at Monte Vista High School, and my project is also the phone-controlled robot. But for my modification, I also used ultrasonic sensor, but it also detects how far an object is from the clock, and it'll show on my app. Let me give you a quick demonstration. As you can see, this is the app I have already connected to the arm. So if I move the claw slider, the claw should open and close. The shoulder slider will move forward and backwards. The elbow will move up and down. And the waist would move left and right. There's also a reset button. It just brings it back to the normal position. And if I put an object, let's say a water bottle in front of it, it would show on the bottom, there's an object detected. It's kind of hard to see, and how far it is from the arm. So this is how we created our app. We use the MIT App Inventor. Now, the MIT App Inventor, there are different kind of components to use. What I use mainly is the label, buttons, and sliders. Each component does different things. I also added some layout to make it look a lot nicer. But as you can see, there are some stuff cut off. This is because the screen size on the app is smaller than the screen size of my phone. And I also had two more components known as the Bluetooth client, which basically connects the phone to any Bluetooth device, and a clock. I'll explain that in a few seconds. Here's the code portion. This first column is the code for the Bluetooth device. Once you press the connect button, it'll show a list of Bluetooth devices that you can connect to. And once you connect to a device, there will be a text saying connected, and it will be in blue. Once you press the disconnect button, the text will become disconnected, and it will be in red. The next column is once the slider position changes, it'll send information to the ESP32. For it to work, once the position changes, it'll send a text of a number and then the thumb position. The number represents which servo is being controlled, and the thumb position is the position of the slider or the degree of the servo. For this block of code, this is the reset button. It just resets the servo to their designated degree. And for my modification, I had to add some code into the app. And what this code over here does is basically, once the ultrasonic sensor detects an object 10 centimeters away or less, it will send in how far the object is from the ultrasonic sensor to the app, and it will display on the bottom of the app showing how far it is and if there's an object detected or not. Throughout the 3 weeks at BlueStam, building and creating these app and robot arm was really fun, but obviously there's a lot of challenges. The main challenge for me is working on the ultrasonic sensor. This is because we only had like a day to work on our modifications, and learning a new component in a day is kind of difficult for me. So that's one of my challenges. And throughout BlueStam, it helped me a lot thinking about my future career, and I enjoyed every aspect of it. And I plan to be an engineer in the future, but I'm not sure which one yet. Thank you. Any questions?
Awesome job, David. Awesome. You said you like all the aspects, but you gotta have one favorite. Like everyone has one favorite. What do you think? What's your favorite part? If you could only repeat one part, what would it be?
Probably, can I just say coding and building?
Yeah, you could say that. Awesome. Awesome job. Great job, David. Next up is Atish. So Atish, when he was working on his project, he encountered this bug. Me and none of the other instructors were able to figure it out. Everyone else was able to like read their data with one line of code, but Atish's, for some reason, that one line just didn't work. So he had to come up with an entire new way of reading his data and being able to use the raw data that was getting inputted into his ESP32, which is really challenging. And he really worked hard and overcame this challenge. But on that note, Atish, are you ready?
Yeah, I'm ready.
All right, let's go.
Okay, so hi everyone. My name is Atish Warren, and I'm currently a rising senior at Carmont High School in Belmont, California. My project is also the phone-controlled robot arm, and the modifications that I made are adding an HCSR04 ultrasonic sensor that allows the robot to close and move an object, and an LED light that lights up when the ultrasonic sensor detects an object within 10 centimeters. I will now be giving a live demonstration of this working, and I'll be switching over to my other Zoom account on my phone. So just be on the lookout for that. Second. Okay, so here is my setup. There's an LED light over there. That's the ultrasonic sensor, and there's the robot arm. If we put an object in front of the sensor, LED lights up, arm opens, arm closes, carries the object. That wasn't meant to happen. I'll do it again really quickly. Okay. So put it in front of the sensor, LED lights up, arm opens, closes, there we go. Drops the object and turns back. Okay, I'll be switching, actually, never mind. I'll be demonstrating the app on my phone now. So if we click the connect button and the ESP32, it turns to blue. And as you can see, if I move the sliders, the robot arm also moves. So the one on the right controls height, and the one on the left controls back and forth motion, and the claw controls the claw, and then the bottom servo controls the waist. So now I'll be switching back to my computer. Okay, so for my presentation, I'll be focusing on the ESP32 and Bluetooth. Initially, I was using the Arduino Uno board. However, I switched to using the ESP32 because of its integrated Wi-Fi and Bluetooth features, making it a better alternative to the Arduino Uno board. And to get the ESP32, I plugged it into my computer, downloaded a separate driver, and downloaded a specific library for the ESP32 in the Arduino IDE. After that, I connected the Bluetooth serial terminal app on my phone and the serial monitor on my computer. And using an example code, I sent and received string text from the app on my phone. I implemented the same logic to my program controlling the robot arm, but this is when I encountered the big obstacle. So the challenge that kept hammering me down for nearly a day and a half was that the ESP32 was not receiving the data I sent from my phone over Bluetooth. After researching and referring to my instructors, I discovered that the serial monitor received ASCII integer values of the text I sent from my phone. And ASCII is just a character used to store data in computer memory. And the challenge was that my code requires a string text with the servo number and the angle in degrees separated by a space. Thus, I needed to convert the ASCII values to a string. And to resolve this problem, I first converted the ASCII values to characters and stored them in a character array. So this is a character array right here. And then I concatenated or added each element of the character array to a string variable. And the solution seemed really simple, but at the time, it took me like a really long time to figure this out. And finally, I was able to send data over Bluetooth after I figured this out. And once I got the Bluetooth working with the serial terminal Bluetooth app that I used for testing, the exact same solution worked for the app I created. And I'll now reshare my screen. So as you guys can see, here we have the data I sent earlier when moving the sliders on my phone app, and getting this was what caused me the problem at first. So the reason I chose to build a robot arm is that I have some previous experiences in programming, and as someone who aspires to be a computer science engineer, it's crucial to also have knowledge in fields such as electrical and mechanical engineering to be an active problem solver and find solutions to whatever complications might arise. My experience here at Bluestamp has been very enjoyable and enriching, considering that I overcame many challenges, not only that one, but there were several others that I encountered while building the robot arm. And my favorite part of the project was definitely adding the ultrasonic sensor and the LED light. And it was a really nice finishing touch to the project. And I automated the whole ultrasonic sequence. So I thought that was really cool. And overall, I was quite satisfied with my final project. And from this great experience, I learned that with patience and persistence, I can accomplish builds and projects that I only previously dreamed of. And yeah, I think that's about it. Thanks for listening. Do you guys have any questions?
That was awesome. Great job, Latish. That was awesome. What was the most rewarding part, do you think? Do you think it was more rewarding, like adding on the modification at the end or solving that bug? Because I know those two have got to be up there with what was the best feeling.
I think solving the bug was like the best feeling, because I thought I had solved it a week earlier, but it turned out that I was just running each of the characters individually.
Yeah, I remember I like saw it. I'm like,
Oh,
wait
shoot,
a second,
not
something
this
was.
And then once I fixed it, the robot arm was just moving from like the phone app, and that was like such a like moment where I was just super happy. Yeah,
The best feeling. Amazing job, Latish. And last up for the remote control for the robotic arm is Michael. One thing I can say about Michael is that Michael really like took the time to understand the nuances and the details of the different parts he worked with, that you'll hear about soon, understanding the math behind it, and really understanding how each individual part works. On that note, Michael, are you ready?
Yep.
All right, let's go.
Hi, everyone. My name's Michael, and I'm a rising senior at Monte Vista High School and in Cupertino, California. And my project is also the phone-controlled robotic arm, which I'll be demonstrating right now. So as you see, I have a phone app with the sliders on it, and I can select a Bluetooth, the ESP32 through Bluetooth, and I'll control the servo motors with the sliders right here. See, right now I'm moving the claw in and out. And I'll move the robot arm back, forward and backward like that. And the waist like this. Right and left, yeah. And I modified the project by adding an ultrasonic sensor up top that automatically closes when an object comes within range of it. I'll do that right here. Oh, it wasn't supposed to do that. Hold up. Yeah. And for this presentation, I'll be focusing on the ultrasonic sensor part of the project and how it works. Right now, I'll share my screen. And so right here is a diagram of a basic gist of how it works. And I'll be comparing it to, I'll be comparing the ultrasonic sensor technology with bats and how they see in the dark. And as many of you likely know, bats are blind and yet can navigate themselves in the dark with great accuracy. And they do this with a technique called echolocation, where they make sounds, that high-pitched sounds, and their ears detect them when the echo reaches back after it encounters an object. And that way they can see, quote unquote, see what is around them and how far everything is. Ultrasonic sensors use very similar methods to obtain the distance from objects. And they do this by emitting sound waves, as shown here, with the emitted waves are red in this diagram. And after hitting the object, they echo back as the blue dotted ones the reflected wave. And the reflected wave creates an electric signal once it reaches the ultrasonic sensor. And the sensor determines the time between the waves release and the electric signal when it returns back. And using this time, it is able to calculate the distance between the sensor and the object using the formula distance equals speed times time. And since the speed of sound is already known in dry air at 20 degrees Celsius, it's 343 meters per second. Multiplying speed times time gives the total distance traveled by the sound wave, or the total distance that the emitted wave travels and then reflects back. To get the distance between the sensor and the object, this sensor will divide this value by 2 to just get this one-way distance right here. And one issue that arrived with the ultrasonic sensor was that it only determines distance between the object, not the size of the object. So when I was doing the automated closing of the claw when an object was coming in, if the object was too big, the servo motor would keep trying to close, even though the object was blocking it. And if this was left unchecked, it might lead to problems for the servo motor. So in the future, a possible solution would be to implement maybe a pressure sensor to have the servo motor stop turning when the objects are held firmly in place, which can be detected by maybe how much pressure is being put on the claw. And in this project as a whole, the challenge that had the greatest impact on me was from the first week, when I was still connecting my robotic arm to my computer with an Arduino. And after a few moments of running the program, the robotic arm would simply stop turning even when I would command it to. And I would debug it by printing to the serial monitor, and it stopped printing too. So I knew that the program was crashing. And I started debugging that after that by individually testing each of the servo motors to see if and there was anything wrong with one particular part of my code. And after determining that my code was okay, my instructor and I agreed that it was an issue of power, where my computer was not supplying enough power to the servo motors, and that was causing the program to crash because the computer didn't like it. And that's when I decided to plug in a 9-volt battery into the Arduino, which solved the problem because now the servos were getting enough energy to run continuously without fault. And through Bluestamp, I came to really enjoy both the building and the software coding aspects of the project, and especially like assembling the arm and creating the app on the MIT App Inventor. Those were the most enjoyable things for me. And after thinking about it, after coming to Bluestamp, I'll look more into both mechanical and the computer science aspects in the future. Yeah, I think that's about it. Thanks for listening.
Awesome job, Michael. That was great. I got one question for you. If you had all the time in the world, I think I already asked this, but what would you add on to the project? I know you had something in mind that involves a claw.
Yeah, I think it would have to do with the claw and the pressure sensor potentially, because right now I just have one object that it's closing a specific amount for. I want it to be able to work for a more variety amount of objects, not just this one. And in order to do that, it would have to have a variable amount of turn, which I don't have right now.
Awesome. All right, so that wraps up our robotic arm segment, but now we're going to be moving on to the gesture controlled. Yasmin's going to be starting us off. Yasmin's soldering iron came late, so she was really like a little bit behind, not her fault, but like the soldering iron came late and it was a big push at the end to try to get this done. And Yasmin worked really, really hard the last couple of days and was able to perform a miracle and get her entire project done. And I'm sure she's really excited to show it off to you guys. Yasmin, are you ready?
Yeah, I'm ready.
All right.
So, hi, I'm Yasmin. I go to Evergreen Valley High School and I'm a rising senior and I worked on the gesture control car. And I chose a gesture control car because in my robotics team, my expertise lies mostly in mechanical, so the sensor work and the coding was a little more out of my comfort zone. So I really wanted to try that. The gesture control car that I built uses an accelerometer and an ESP32 to send values to the ESP32 on the car. And the motor driver works by using a low current control signal, which powers the control circuit, and turns it into a high current signal. These low and high current signals are used to control the direction of the robot. So, for example, to turn left, one set of motors goes backwards while the other set of motors goes forwards. So I'm just gonna show a quick demo video of my car. So let me just. Okay, so here it is. So you might notice that the two motors on the left are stalling. That's because I guess like the wheels don't have that great traction. So um, when one side tries to push, the other kind of stalls. But it still turns left and right, so I'll take that. Here, let me just stop sharing. All right. And then I guess like one of the biggest challenges I had when working on the car was to get the ESP32 to communicate with the accelerometer. I came in with no knowledge on how the ESP32s worked, and I had to refer to like multiple different sites and try to piece together information from each one. And sometimes errors in my code were just like a wrong letter or the wrong order, so I had to like research and like really be diligent to get the code to work. One of the biggest lessons I learned building on top of that was to just be patient and take a break when there's a bug in the code. Multiple times throughout the project, I learned that like looking at the code with a fresh pair of eyes would really help kind of identify the problem. Any questions, I guess?
Awesome. Great job, Yasmin. That was great. What part did you like more? Did you like the building, like the with the motors more? Did you like the coding with the ESP32, like using the accelerometer? What was your favorite part? What do you think?
I think my favorite part was I think I like felt the most rewarding when I was like moving the accelerometer and like my car was also moving with it. So I don't know. I just thought it was cool that I was able to get the sensor values to like drive my car.
Yeah, it's super cool. Like seeing it all come together at the end, like all the different components working together. Awesome job, Yasmin. Jesse's gonna introduce the next person. Take it away, Jesse.
So Lorelai is my one and only student that was able to make it here tonight. She's also running with the gesture control car, which is a very awesome project, as you guys just saw. Lorelai came into the program relatively new to Arduino and all that stuff. And this project is like very complex because it has so many different levels to it. You got the regular car, the moving, and also these serial connection between two devices. So I was a little concerned that, maybe she wouldn't be able to finish it. But first day in, we talk about like what possible modifications she could come up with. And she told me I want to make it fly, which for those of you who don't know is a super ambitious goal because flight is just like a crazy concept, and it's even hard for even graduate level students to achieve. So right then, I knew if that was her modification that she was shooting for, that she would have what it takes to get all the way to the end of this challenging product. And 3 weeks later, here she is with a finished product, and I'm very, very excited to introduce her. So Lorelai, would you like to present your project?
Yeah, of course. Hello, I'm Lorelai, and I'm an incoming sophomore at Irvington High School, and my project is also the gesture control robot. Here's a video demonstration. Um, So the gesture controlled robot, as its name suggests, is a robot which essentially moves according to different hand gestures. It is composed of three main components: the motor driver, the accelerometer, and the ESP32s. The accelerometer is the main device which measures and determines the orientation of your hand, and it's connected to the sender ESP. The accelerometer values is transmitted from the sender ESP to the receiving ESP on the robot, which moves the car accordingly. I think the reason why I chose this project was because the idea of being able to control a robot wirelessly without the use of like controllers or buttons, etc., was extremely interesting to me. And along with the gesture controlled robot, I also added my own modification, which was the addition of LED lights. And they're essentially used to sort of replicate the taillights of regular cars. So for example, if the robot is stopping, the red light would turn on. And if it's in reverse and going backwards, the white lights would turn on. I think during this entire process, I faced two main challenges. And one of them was to successfully transmit or send a value from the sender ESP to the receiving ESP. And another one was to successfully make the motor driver to work and essentially the motors to work properly. As well as facing many challenges, I also learned a lot of lessons throughout this entire process. As I was fairly new to Arduino and software programming and development, I learned how to use it and how to code. I learned about the different components of my car and how to control it using coding and how to troubleshoot as well. And overall, I think this experience has made me more interested in engineering. I think being able to design a product, design a robot, and add modifications to make it do what I want it to do has made me more interested in mechanical engineering. Thank you. Any questions?
Yeah, I got one for you. So given another student that may be in the same shoes as you that has not so much experience with Arduino when they're first starting out on a new project, how would you recommend they go about like accomplishing, teaching themselves everything they need to know to achieve this project?
I think for me, when I was just starting to research what Arduino was and how to code, I think one of the biggest things that helped me was probably researching online and looking through the example codes which are provided in Arduino. Those looking at those and figure out what they did really helped me create my own code for the gesture control car.
Okay.
Yeah.
All right, Theo, I think we're back to you.
Right. Next up, we have Alan. Alan started off with a pretty simple project and was able to complete the entire thing in 1 week and went for one of the craziest modifications that I've ever seen. It was a new part new to anyone at Bluestem, and he really took it and delved really deep into it. I was able to make a really awesome project that he's going to tell you about right now. Alan, you ready?
Yeah, I think so.
All right.
All right. Hi, my name is Alan. I go to Amador Valley High School. I'm a rising sophomore, and my original project, my project is an object tracking laser. So my original project was a pretty simple, basic project. It was a laser turret. It's basically two servos connected together, which would allow the laser to move up, down, left, and right. And the code was written so that the laser would spin to random positions and fire at random intervals and fire random shots, right, anywhere. And I chose this very basic laser project because this is my first, engineering or mechanical engineering project I ever made. And I thought that a laser turret was not only very cool, but also pretty simple. And I thought that I could like wreak a lot of like cause a lot of chaos with the laser turret. But then after about like a week, I had already finished my project. So one of my ideas from the beginning was to have the laser track objects or like track a hand or track an eye. But then I ended up choosing a camera called a Pixie Cam. And what this would allow me to do is it would allow me to the camera would find like an object based on the color, and I could take inputs in from the camera and have the servos like carry out the actions. So right now I'm gonna use my phone and on my computer. If I open up the software, I can share the what the camera is seeing. So yeah, give it 1 second to load up. Let me turn on this light. Okay. On my phone, I'm also gonna start the video. Flip it around so you can see the servo motors move. Right now it's tracking a blue sponge. So I'm gonna hold the sponge right behind the camera. So it should look like this camera is kind of tracking the phone. On my computer again, let me share my screen. Okay, hopefully you can see this. Hopefully I run into 0 errors. So right now the Pixie Cam isn't detecting anything blue, so it's not going to do anything. Now using my phone. Okay, sorry. So as you can see, the camera has detected the sponge and it drew a box around it. And given after some time, when it finds the center, it'll shoot a pulse of laser that I don't know if you guys can see due to the lack of frame rate from Zoom. So now if I were to move like the sponge to the left, the camera would slowly pan its way over. Sorry, wait, I don't know if you can see the motors moving. I can't tell.
Yeah, we were able to see it. It
Okay,
looks awesome. It's
Can you
awesome.
see it now?
Well, now the camera's flipped on you, but
Okay.
we just saw it before. It's awesome.
So, oh god, it actually just broke. Crap. Anyways, don't worry about that. I guess the hot glue job wasn't done well. Anyways, you're able to see a little bit of it. Camera is able to detect objects, and then I was able to use code to take in inputs from the camera and have the servo motors make it move. Yeah. Okay, so the greatest challenge that I faced when working on this project was probably the Pixie Cam, because again, like Theo stated, no one in BlueStamp, I guess, played with this thing yet, and it was mainly just me looking at the Pixie Cam API when trying to find certain things like how to make servos rotate towards an object. I was usually met with because like PixieCam also sells this thing called like a pan tilt demo thing. So it was mainly just videos showing how to get the pan tilt demo thing to work. So yeah, it was mainly just looking through the PixieCam API and figuring out how I could take in inputs from the camera. So I learned a lot of things during BlueStamp. Because I came in here like a clean slate, I did not know what I was doing at the beginning. So I learned a lot about the Arduino. I learned a lot about coding on the Arduino. I learned about like how the circuits work, how to wires, and like where to plug in the wires. So it was really fun getting my first project to work. And yeah, hopefully in the future I can continue to create amazing projects like this, I guess. questions.
Awesome job, Alan. That was great. I was gonna say, looking back at it now, looking 3 weeks ago, you came in with no knowledge. Are you like shocked that you were able to produce this awesome laser turret, like tracking laser turret, or were you like thinking the whole time, like, I'm gonna be able to do this? Like, this is a crazy accomplishment coming in with nothing.
I don't know. I got the laser thingy, but then I thought that there would be like more steps to the laser thing, but I don't know. I think I finished it a little too quick. So it was really cool getting getting my first project done so quickly.
Yeah, the amount that you were able to accomplish in 3 weeks is really, really amazing. Awesome job, Alan. All right, last up, we have Saksham. I think you guys are all gonna really like this project. It's super cool. Saksham was in office hours pretty much every day working on this project. It's a project he came up with on the spot. He came in, pitched the idea to Dave and Gavri, and they were like, all right, you're on board, you're ready to do this, then we're gonna make this happen. So Saksham built this Rubik's Cube solver, and I'll let Saksham take over from here.
Hello, my name is Saksham, and I'm an upcoming junior at Arlington High School in California. And so this is my RoboCuber. So it's basically, there are two servos here, like here and there, and it's controlled with Arduino. And then I coded on Arduino IDE for it to solve the Rubik's Cube. So I thought of this project because I've recently been passionate about Rubik's Cube and speed solving, and my passion for it with also including my interest in building contraptions goes well together. And I understood, and I saw the video of a robot solving solving a Rubik's Cube in a fraction of a second. So that was so interesting to me. So I'm like, I want to take my first step to reach that place where I will be able to achieve that. So this is my entire project. I'm going to do a demo solve. So it's going to first scramble it, then there'll be like a 10-second delay, right? And then it goes, and then once you see that, then it will start solving again. And since there are only two servos and it's a pretty basic one, I'm only doing 3-move scramble because it will take too long otherwise. But I've already tried an 8-move and a 12-move one, and I have a video of 8-move. So yeah, if anybody's interested, I can send that link. But so it will start now. Okay, so now the 3-move scramble is done. Now it's going to start the solving shortly. So. And it's basically done, but now it's going to go back to its original state where it started from. So yeah. So this is basically the finished outcome. And if you're not familiar with Rubik's Cube, basically it's like a twisty puzzle. So in this case, as you can see, it's a twisty puzzle, and then all these servos. To control them, you need to use angles, and my favorite part that goes into my favorite part of the project. My favorite part of the project, my favorite subject is maths. So being able to use matrices and those matrices, angles, measurements, and all those fun different concepts of maths, and being able to apply them into my project was something I was very excited about, and I was happy the entire time doing it. And also when I was writing the code, I was thinking, okay, so if it's going to move like 150 degrees, and where is it going to go at? And then trial and error. So that was really fun. However, there were still a lot of challenges. As it was a custom project, I didn't have like I tried my best to work as much as possible on it so I can finish it. And I'm really happy that Bluestamp allowed me to work on this custom project. And special thanks to Theo for helping me, like he said, I went to office hours a bunch. So like most of the time I was on office hours, or most of the office hours, and Theo helped me a lot with fixing all the fixing all the problems. And the biggest problem I would say was sticking the wedding together. As you can see, all of it's an angle, and that angle with all of like using Pythagoras theorem, law of science, and everything. I had to use like specific measurements and everything for it to work properly. I don't want anything to have too much support, too less support for holding a lot of weight. And so yeah, that's my favorite. That's my favorite part. And then the challenges. And in the future, since this is my first robotics project, in the future, I hope to take this to the next level and try to make it faster, try to improve on it, try to improve the code and everything. And I'm very glad that this gave me the opportunity to be able to get to my step one, and I hope to be able to go to next steps as well. So yeah, thank you. Any questions?
Dr. Sham, that is still, every single time I see it go, it's one of the coolest things I ever see. I can't believe you got this working in 3 weeks. It's really insane. And for all you guys that don't know, servo motors can only rotate 180 degrees. So Dr. Sham had to make an algorithm that would basically allow you to rotate 360 degrees using only 2 motors that can only turn 180 degrees, and one of them could rotate and the other one could push. So he worked super duper hard to get this algorithm and figure out this project. And like, it's just one of the coolest things you've ever seen. I mean, I'm sure Dave this is probably the only time he's ever seen a project like this. And like, I know Dave was already saying to Gabriel that they want this to be a project in the future that people could do. It's that cool. And you did an amazing job with this, Dr. Sham. This is really, really cool. Yeah, Jesse.
I have a question.
All right, yeah, Alan.
What's your fastest time, Shaksham, for like actual speed cubing?
For my one, my personal fastest is 14 right now, like 14.xx. I don't remember exactly, but yeah. But like in the past 2 weeks, I would hope I improved, but I've been focusing on this, so I hope it improves faster. Yeah.
That's awesome. That's so fast. I think the best I ever got was like a minute. That's crazy. 15 seconds. Jesse, you got any closing words?
Yeah. So these were some incredible projects. I really enjoyed seeing these all come together, especially seeing Theo's group, because I've been working with my group. So it's really nice to see all these other projects that I haven't worked with either. And seeing some of these things that students are able to come up with is incredible. But yeah, before you guys leave, I just wanted to thank everyone for coming, and thank all the students for the tons and tons of hours they put into their projects this week, and for coming to class, showing up, and working with us. It was an absolute honor to be your instructor, and I'm sure Theo feels the same. It's just an incredibly rewarding experience for us to see all the work that you guys are able to put into these projects and get these amazing things accomplished in just 3 weeks. So round of applause for all the students and all the hard work they were able to put into this time here. And thank you so much to everyone for coming.
One more thing I just want to add on. Your engineering doesn't have to end here. You guys have a huge box of awesome tools that you guys could use, awesome sensors. Continue to work, continue to use all this awesome stuff that Bluestamp sent you. See what else you guys can make, because you guys, your minds, like, there's no limit to what you guys can do, especially with the parts that Bluestamp gave you and the knowledge that you guys are able to collect over the last 3 weeks. Like, the sky is really your limit for all of you guys. And you guys did an amazing job over the last 3 weeks. Like, we're all really proud of you guys. I'm like excited to see where this goes from here.
Yeah, absolutely. I wanted to echo that and also suggest that you can update your website. So if you make your project bigger, cooler, better, faster, or you make an entirely other project, continue to update that website, because when we give recommendations to students, we always include that link to your website. So the cooler you can make that, we will do our best to push that information out there. So please continue to build cool stuff. Come back to Blue Stamp, do stuff on your own, come into Blue Stamp in person. Any of it can all work. So yeah, thank you for all coming. Parents, thank you for sending your students, and students, amazing job.
All right, and yeah, that